triumph of mathematical and mechanical skill is this great new automatic calculator at Harvard University. Intricate problems in mathematics, put through the machine in coded form on tape, are accurately solved in a minute fraction of the time required for human calculation. Designed to expedite all forms of mathematical and scientific research, the giant mechanical brain will work for the United States Navy until war's end.
This is CS50. The past was a magical place, but if you've ever wondered what that device is in Harvard Science Center, it's indeed part of the Harvard Mark I, and it's on display there now for the past many years. And what you'll see embedded in problem set 1 is a look behind the scenes at what that device did and does from Professor Harry Lewis, who's in the computer science department here. So more on that in just a bit. But today we begin to transition from last week to this, and we'll bring mention of one photograph here that's actually quite famous. Does anyone know what this here is on the screen? At least according to myth. Yeah. So supposedly the very first actual bug in a computer. Now, in reality, the word bug for a mistake in a program has been with us for some time in the physical world, and this was one of the first documented times where someone actually plucked a large moth out of the Mark II computer, put it in the binder, and then recorded it as the first known bug to have actually been found physically. So thus was entered that into today's lore. Everything from last week is available online, and in particular resources that you might not necessarily notice, especially if coming here in person. So one of the teaching fellows every year makes a canonical set of notes so that you needn't keep your head down trying to transcribe most anything that might happen here in class. So realize that those so-called scribe notes are online. Certainly the slides and the source code that we use in class, we make full text transcripts available as well. So if you vaguely remember some term and want to look it up a little more readily, realize that all of that is searchable online, as well as walkthroughs as well. Indeed, today we begin to look at a lower level programming language, soon to be known to us as C, and it's very easy to sort of get lost after just a few moments' time, and then sort of wonder how we actually got to some more complex example from the simplest. And so realize we'll cherry pick during class some of the representative examples, but realize that so much more is also available online so that you can work through it at your own pace, however you are most comfortable. But we left off with programs that were just this. So I click the green flag, and what does this program do? It says hello world, right? It makes the cat say hello in his little world on the top left-hand side of Scratch's user interface. But we started to introduce some terminology last week, and so things like this we called what? What might be the generic term for this? Yeah. A method or a statement, sure, it's an action, do this. And yet there were other shapes to Scratch besides these so-called statements. They were also things like this, which we called what? Yeah, so a loop. And in this case, this thing repeats obviously 10 times. There's a forever block. There's a couple of others. And today we're going to see how to translate this to a more modern world, if you will, even though it's going to appear at first glance to be much more arcane. But those were indeed loops. And then we had things like this, which had this shape and essentially asked questions. And we referred to these as what? Yeah, Boolean expression, something that is either true or false, yes or no, 1 or 0, however you want to view the world, but we called those Boolean expressions and we plugged them into conditions or branches. And in the world of Scratch, everything nicely interlocks in terms of its shape if it makes logical sense to do so, but you don't have to stop with just doing one thing conditionally. You can have a proverbial fork in the road and do either this or that if a condition is true or not. And then, as you'll see if you haven't already, you can even nest these blocks. So Scratch grows to fill the shapes that you might want to insert into it so that you can actually express most any logic that you might want to do. Now, a few words of announcement for both here and New Haven. So sectioning begins today. The URL for this is on the course's website. For those unfamiliar, sections will be an opportunity to get together in a much more intimate environment than Sanders allows, with 10 to 20 classmates with a teaching fellow at different tracks and different paces if you so choose. Indeed, the course offers different sections for those less comfortable, more comfortable, and somewhere in between. And the rule of thumb here is that there's no formal definition, but you know you are. If you're less comfortable, you kind of know it. You're a bit intrepid about the idea of stepping foot perhaps back in the classroom or showing up to an in-between section. If you've been programming since you were 6 years old, more comfortable is perhaps to you. And if it's kind of a toss-up, that's exactly what the in-between is meant to be. Now, in the meantime, for a class this size, it takes us quite some time to section everyone. So we have so-called super sections coming up this weekend and early next week. So take a look at the course's website for those that are course-wide and also filmed for those who cannot make them. And sections themselves will start in week 3 of CS50 Zero Index. Problem Set Zero is already on the course's website, and realize that you do have 9 late days this semester. So this is an upgrade from last year when we had 5 late days. So if you're wondering, we have 9 problem sets, and you have 9 late days, each of which that you can only spend 1 per week on. That effectively makes all of the problem sets due Friday, but the goal is to put a little bit of psychological pressure on you to try to get things in on Thursday, because as you will soon discover, for better or for worse, most everything in the software world ends up taking much longer than you anticipate. And so consider it a sort of opportunity to help yourself to target Thursdays, but take comfort in that, yes, everything is due Friday. And if you submit them on Thursdays, that's wonderful. There's no bonus points or extra credits for meeting that deadline. It's meant to be a crutch only. And office hours, both here and in New Haven, in person if you'd like to meet with any of our courses, teaching fellows and CAs for assistance. All right, so now let's make this more real. And for a moment, it's going to start to get a little more arcane, but very quickly on Friday and next week, will we be able to do so much more than we could thus far in Scratch. So we introduced code last week, albeit pictorial. It was puzzle pieces. And we formalized that as something called source code. But what did it look like? Well, it looked a little something like this. And in fact, just to kind of tease where we can go with this, I'm going to go ahead and open up a window here. And I'm just going to choose New File. And I'm going to save this file as something like hello.c. More on that choice of words in just a moment. And this is how someone might go about writing a program. Include standard io.h, int main void, and then open curly brace, close curly brace, printf, hello, comma, world, \n, semicolon, save, done. Okay, I've written my first program, but it's going to incredibly underwhelm because when I actually run this program, of course, by first writing make hello, and then /hello, and we'll go through this in much more detail in a moment, that's all it does. It doesn't pop on open any windows, it doesn't do anything particularly fancy. All it does is what I told it to do. But how do we get to that, and how do we build upon that? Well, let's introduce a few different concepts here. So one, we're about to start using a program called a compiler. Compilers exist for Mac OS, Windows, Linux, any number of operating systems, and we'll soon introduce you to the environment that we will be using. But a compiler is just a general term for a piece of software that takes source code and produces object code from it. In other words, if you have as input your source code, something like what I just typed, it ultimately produces object code. And object code is really just a fancy way of saying it outputs zeros and ones. In other words, source code, even though it's going to look a little arcane and a little less friendly than Scratch at first glance, it's at least something that we humans can understand. It kind of looks and sounds like English, even though it's very succinct, whereas programming in zeros and ones, as our predecessors had to do some years ago, was not a particularly fun challenge. And yet this is what the computers still understand, so a compiler gets us from source code to object code. It's like opening a file with the compiler, and when you save it, you get those zeros and ones. So we'll see how to do that in just a moment. But let's now try to provide a bridge between last week and this, so that even as we get hung up on things like curly braces and semicolons and parentheses and all of these intellectually uninteresting aspects of programming that very understandably trip people up early on, realize that all of the ideas today are the same as last. So last we saw this example here, Hello World program. Well, starting today, if we want to implement that same program, it's going to look a little something like this. And we'll explain before long what int and main and void and all of that is, but at least I see here already the familiar Hello World. Meanwhile, things like functions, say hello, is very simply going to be a very simple statement like this, printf hello world, with some quotes, with a / with a semicolon, but more on that to come. Loops, meanwhile, this is a loop that, of course, says hello world forever, and this one's going to look a little weirder than the last, but if I say something like while true, I can then print out hello world again and again and again and again. As you can kind of start to infer here, this convention of using curly braces is kind of like embracing the indented line of code there, the printf line of code, much like the yellow puzzle piece up above. So we're not going to say forever, we're going to say while true, but we'll see why that is in just a bit. Meanwhile, if we have a loop like this, where you repeat something a finite number of times, this one too, it's going to take a little getting used to, but it's going to say 4, int I gets 0, I less than 10, I plus plus, and then printf again. But there's going to be patterns. And for those of you familiar with AP computer science or Java or any number of other languages, almost all of these constructs thus far should look mostly familiar. So variables. So here's a simple Scratch excerpt that sets a variable called counter to 0, and then it forever says the counter, and then it changes the counter by 1. So it starts with 0, and then 1, 2, 3. Well, how might we introduce that in this new language? A little similarly. Int counter equals 0, while true, which is that same idea from before of doing something forever. And I'm just going to printf, and now it's getting a little strange, %i, but more on that to come. But these ideas are exactly the same. We just now have to adhere to the syntax that the computer is going to demand of us. Boolean expression, something like x less than y, or x less than y and y less than z. It's going to look a little something like this, with parentheses, just like in math, for good measure, to just ensure that the order of operations is as we intend. And now conditions. So if x less than y, say x is less than y. Else, if x is greater than y, say x is greater than y. Otherwise, logically, x must be equal to y. So you might implement something like this in Scratch, or you might implement it in this syntax. And again, the curly braces are kind of giving us the same shape as the puzzle pieces, but the syntax now is perhaps starting to follow some patterns. So what does this give us here? So we're back then at our main program. Let's actually now do something with it. So in this very first line, we see sharp include standard io.h and then some weird angle brackets. Below that, int main void, and then printf hello world. So just take a stab. Someone who's never programmed before, at least explain one of these lines, using perhaps some of the jargon of last week. What is printf, for instance? Yeah, it's a function or a statement from last week's terminology, and it's an action that's doing something. Now, this function or this statement, does it appear to take some kind of input? And in what sense does it seem to take input, if so? Input. What do I mean by that? So, Yeah, so Scratch had a few puzzle pieces where you could parameterize it. You could tell the repeat block how many times to repeat, so that was an input of sorts. And just like Scratch had a little white placeholder for the number you would type in, so do we use in this text world parentheses to kind of give us that circular shape into which we can plug our inputs. After all, tens of years ago, when this language called C was invented, no one anticipated that one of us, some years later, would want a function that says hello. Right? It would be nice if there were a puzzle piece or a keyword that's called hello that literally just says hello, but we don't need that. We can have something much lower level, like a generic print command that takes input and prints whatever we want. So notice now the pattern that will start to emerge. Open paren, close paren is apparently embracing the input, and then I see double quotes on both ends. There's still a weird \n, but hopefully now you can start to visualize at least that printf is taking in some form of input. Not as user-friendly as Scratch, but it's just like having plugged in some value there. All right, now let's actually do something with this. So some of you might know from having shopped the class before or chatted with friends that for many years we used something called the CS50 appliance. This was a term describing a technology called a virtual machine, which is a piece of software that your predecessors would download off the course's website for free. They would also download a free piece of software called a hypervisor, something called like VMware or VirtualBox or any number of other tools. And on their Mac or PC or whatever computer they had last year and in years past, they would double-click an icon to run this software called a hypervisor. And then inside of that program, they would open the CS50 appliance. And the effect was that whether a predecessor of yours was running Mac OS or Windows, he or she then subsequently had a new window on their screen running CS50's environment. So a virtual machine lets you run one operating system inside of another, and that's exactly what we did. Throughout most of the course, we use an operating system called Linux, specifically Ubuntu Linux, and this is a very nice way in years past of making sure that everyone in the course just had the same environment, and you can use any kind of computer that you actually want. Among the downsides, though, were it was like 2 gigabytes to download this thing. It didn't necessarily work super well on people whose computers that maybe only had a gig or so of RAM or not too many gigahertz of CPU speed. And so this year, for this and other reasons, have we been transitioning to this environment. the so-called CS50 IDE, which is based on open source software and a supported platform that's a company called Cloud9 supports in Europe, that allows us to have essentially that exact same environment as in years past, but in the so-called cloud. So what is the cloud? You probably clicked its icon on your Mac or PC. What is the cloud? Yeah. A little louder? Yeah, it's just a bunch of computers elsewhere that store data and run software and the like. So it's really just the word du jour of describing rentable computers that live elsewhere, that you and yourself don't necessarily own. So when your data or your programs are in the cloud, it just means it's on someone else's computers elsewhere and not most likely on your physical laptop or desktop. And so that's what CS50's IDE now is. Henceforth, you'll go to a certain URL that will introduce you to in problem set 1 later this week that will then, upon logging in, give you this environment. And much like Scratch had a few different panels involved, so does CS50's IDE have exactly that. On the top left-hand side here, you're going to see a familiar file browser. So any of the files that you put into this environment are just going to be listed there, files and folders. On the top right here, you're going to see a place where you can actually write your code, initially in C, later in the term in PHP and JavaScript, and perhaps for final projects, Ruby or Java or Python, or any number of languages are supported in this environment. It's not at all tied to CS50 specifically. And then in the bottom corner here, especially for those more comfortable, you have something called a terminal window. And this terminal window allows you to execute any command that you want in this cloud environment. It allows you to install any additional software that you want because you have so-called root or administrator privileges. So in other words, even though this is ultimately hosted in the cloud, and even though we have simplified it to some extent by default, literally introducing, thanks to Dan Armendariz and Dino and Dan Bradley on CS50's team over the past many months, a less comfortable mode that hides a lot of the initially confusing distractions, everything there exists to represent a typical computer system that you might use in the real world. So what does this all mean, and what can we actually do with it? Well, let's actually take a peek at a program. So I'm going to open up the actual environment here, which is just a Chrome browser, which could be Firefox, could be Internet Explorer, or some other browser as well. It's full screened here for the moment, and I want to actually tease apart what this program was. So let's take a look by zooming in up top at what I did and how I got here. So here's those exact same lines of code. So this is the statement, as you mentioned earlier, or the function that says hello. The curly braces on line 4 and line 6 presumably kind of envelop that line to associate it with the essence of my program. So indeed, this keyword main that's up there on line 3, you can think of that as the equivalent of that when green flag clicked block in Scratch. So that's all we have here is when green flag clicked, print or say hello world. But let's take a guess now at what this first, more arcane line is. Sharp include open angled bracket standard IO dot H close angled bracket. What is that perhaps doing, especially if you've programmed before in some other language? Yeah. Yeah, exactly. So this is giving you access to a library, so to speak, of functions. And a library of functions is functions that someone else wrote, either recently or long ago, so that you don't have to reinvent the wheel. For instance, we don't have to know in 2015 how to write code that puts a character on my screen. Someone else has figured that out with the printf function so that I can sort of abstract away from that or layer on top of his or her code and now just take for granted that any program I write can print something to the screen. So this first line there in step 1 includes the so-called header file for the standard library. So C, the language in which we're now working, has a standard library with lots of functions. Printf is one of them, and that first line of code means give me access to those functions so that I don't have to reinvent that wheel. Now let's go to the bottom window and do exactly what I did before. A moment ago, when I was whizzing through the code, typing it out for the first time, I very quickly typed make hello. What was that all about, would you guess? What was I doing? Yeah. Never mind, it's okay, yeah. Yeah, I was just compiling it, right? Even if this is completely unfamiliar to you, it's pretty English-like. It's certainly not zeros and ones, so I still need to run it through that so-called program, a compiler that's going to take it as input and produce output. And at least for now in this Linux environment, but this isn't prerequisite, this is just where we'll begin, you generally interact with computer systems like this via a so-called command line. So with a blinking prompt and your keyboard, and not so much your mouse, and not so much windows and icons and menus, rather everything is textual. And even though this feels at first glance perhaps like a step backward, it's actually a much more powerful and expressive way of controlling a computer, especially as you yourselves become more comfortable from less. It's going to allow you to do a lot more things than just what Microsoft or Apple allows you to do with their graphical operating system. So when I hit enter now, nothing happens this time because apparently the program hello is up to date. And what was the command I ran after that? /hello and hello world. Now let's take a step back for just a moment. It turns out that make hello is just a simplified way of compiling a program. Let's just introduce one piece of jargon, but then move away from it since it's not all that interesting for today's purposes. But the compiler we're going to start using is called Clang for the C language. And this is a program that's run just like we did at the command line there. And so if I want to compile a program that I have written in a file called hello.c, I literally just type clang hello c, enter. The funny thing is, for historical reasons, if I don't specify the name of the program that I want to output, if I don't specify a file name for those zeros and ones, a very weird convention was adopted years ago where it felt kind of a good answer at the time. Well, let's just arbitrarily call the first program we compile a.out. A comes first in the alphabet, out, it's the output, so we will call the program by default a.out. And that's fine, because if I want to run the program in this text-based environment, I just type /a.out, enter, and it would run exactly as before. So let's see that real fast. So if I go back to my source code in CS50 IDE, and I instead do this, clang hello.c, enter, notice nothing seems to happen, but almost always in this Linux environment, when nothing bad seems to happen, that means something good actually happened. If you don't see an error message, all is probably well. And indeed, if I now do /a.out, enter, I've run my same program. I still have the hello program from earlier, because indeed, it's going to be so much nicer to just type make instead of remembering these incantations of commands. But let's see how we might improve upon this nonetheless. So this is the command to compile the code. This is the command to run the compiled code thereafter. How can I specify a file name? Well, let's just introduce one more piece of jargon. When you're in this text-based environment, you're going to want to specify things called command line arguments, which is just a fancy way of saying other words at the prompt that tweak the behavior of whatever program you're running. So specifically, the program I'm running, by typing the name Clang, is the program called Clang. So this is sort of the old school equivalent of double-clicking on Microsoft Word or some program's icon. I'm instead just typing its name. But in this version of the command, I then have -o space hello.c. So even if you've never played in this world before, just take a guess. What does -o hello do? Or what does it tell Clang to do? Yeah. Yeah, it just sets the file's output to be hello instead of the sillier a.out. And indeed, let's try this. So if I now do, first let's do this, rm hello. That's remove, and it's going to say remove regular file hello, which is unnecessarily arcane, but it just means do you want to delete the file? And I type Y for yes. And notice, if you were glancing at top left, it did disappear from up there. Let me now do clang -o. And I'm going to go ahead and do hello in all caps, hello.c. Now, if I do /hello, what would you expect? Maybe it's case sensitive, maybe it's not. Let's see. No such file or directory. And we can kind of cheat by just looking at top left. What did I obviously save the program as? All caps hello. So indeed, that's going to make a difference. So now hello world is back. Now, this is all fine and good and all very mind-numbing to sort of get bogged down in these details, but understanding them is good. Typing out these increasingly long incantations, not going to be particularly fun. So people in the world invented another program some years ago called make that quite simply allows you to type make, the name of the program you want to make, and make is smart in that it will look in the current folder, aka directory, and if you have a file called hello.c, that is the file it will compile for you into a program called hello. So it's a much simpler way of doing the more cryptic commands that we did earlier. And we have pre-configured CS50 IDE to know that it should do -O and a number of other flags or command line arguments that we'll see before long. But let's now actually do something more interesting. Just typing out hello world all the time isn't all that compelling. So let me go ahead and change this program and say hello David. Now I'm going to go down here. I'm going to go ahead and do make hello. And again, now you're seeing, make is showing you the longer sequence of commands that it's doing because we've pre-configured it that way, but we needn't worry for now what it's doing other than it is compiling. /hello, hello world. What's wrong? Yeah. Yes, so newbie mistake, right? I noticed this is super subtle, but the asterisk here in the tab just means you haven't saved it, and browsers and other programs do this sometimes. So Control S or Command S should save it. Now let me go ahead and rerun the program. Recompile it, right? So it's a multi-step process, none of which is particularly complex, but anytime we change the file, we need to change the resulting zeros and ones and /hello. Wow, so this is very underwhelming that we've just printed out this. Let's make things a little more dynamic now. Well, it turns out that like Scratch, C supports variables. And it turns out if you want to have a variable that stores not a number like we typically did with Scratch, but like a word or a phrase or a name, you can specify a variable to be of type string. So we'll see more of these in just a moment, but it turns out that C and a lot of languages like it have very specific types of variables. And it's not just like algebra where you get an X, a Y, and a Z, and those are just always numbers. In a programming language, you can store numbers, you can store individual characters, you could store whole words, you could store whole images, whole sound files, and the like. So we need to specify what the type of our variable is. And by convention, I'm going to call my variable S, just because it's succinct, and S stands for string. And then I'm going to store inside of this variable, just like with Scratch, when I use the set block, I'm going to use the assignment operator in C, which nicely enough is the equal sign. But the equal sign does this. It moves something from the right into the left-hand side of the expression. So what I have done, to be clear, in line 5, is I've declared a variable. I've told the computer, give me memory for a variable, call it S, and know in advance that I'm going to be putting a string in it. And a string is just a sequence of characters. It's a word or a phrase or a paragraph, but it's a sequence of characters. It's not numbers. What string am I going to be putting into that variable? Well, apparently, quote unquote, Hannah. Now notice the pattern that's emerging. There's a left-hand expression. There's a right-hand expression separated by the equal sign. And just take a guess, if unfamiliar, nonetheless, with what the semicolon is doing. What's it presumably doing for us? Yeah. It's just terminating the line, right? The computers want to be bluntly told literally what to do. Like the peanut butter and jelly sandwich example, if you don't specify exactly what you intend, it might be left to judgment or error. The semicolon means that's it for this command. It's being super precise, and it's a very easy thing to leave off. So now this program doesn't seem to be behaving any differently until I make it more dynamic. So rather than hard code my own name, let me put a placeholder value. And it turns out that, and I know this from having read the documentation and used the function for years, that printf was designed to be dynamic. You don't have to know in advance what words you want to put in it. You can instead have a placeholder like %s, which is going to tell the computer, put a string here. Which string do we want to put there? Well, it turns out that between these parentheses, which remember demarcate the inputs to a function, if you have a comma-separated list of things here, we can actually pass in multiple inputs to a function. So just like some Scratch blocks, you might not have played with them for your projects yet or at all, some Scratch blocks have 2 inputs, 2 white boxes that you can type numbers or words into. So does C have functions like printf that can take 2 inputs. And again, this comma is separating them. So in English, again, even if you've never programmed before, by that logic, printf is a function, takes 2 inputs, one of which is a placeholder. What would you hope printf is going to do with this input? It's going to say, hello, Hannah, hopefully. So to do this, we need to save it. I'm going to zoom out. I'm going to go back down here and say, make hello, enter. Oh, something's wrong. And actually, this is quite overwhelming. I have like 6 lines of code and like 12 lines of errors. So Look forward to this. So what's going on here? So the best rule of thumb here, especially when you're starting out, don't get distracted by the stuff at the bottom. In fact, I very deliberately just scrolled up because very often, computer's not all that bright of a device. It's going to get confused. If it sees one thing that it doesn't understand, it might mistake other lines of code as incorrect, even though they're perfectly fine. So you always want to work top down through the errors. And admittedly, this is super arcane at the moment. Error, use of undeclared identifier string. Did I mean standard in? No, I meant string. And it's pointing at, maybe it's a typo. It's sort of like spell checking in a very geeky way. But the reason here, and you'll know this just by practice, is that it turns out that string does not exist in C. In fact, C is a particularly old language, and it's very low level, and it doesn't have a lot of features that you might have grown up with if you have, in fact, programmed in Java, as some of you have. But you can teach it new things. And indeed, we have done this in CS50. Even though by this end of the semester, all of these training wheels will have been taken off, what we do in these first couple of weeks initially is we also have you include cs50.h, which is a header file. More on that in the future. It's a file that contains functions that we have written for you. And among those functions is functions for getting input from the user, like strings and numbers and real numbers and more. But it also has a few shortcuts. It defines a Boolean as a data type. C does not have true or false. But we can give it the notion of true or false by way of this library. And it also doesn't have a string built in until we include this line. So this line of code tells the compiler, hey, Clang, look in this file for a whole bunch of code that CS50 has written so that anyone using this file can take for granted the features they've added. So now let me go ahead and clear the screen. And if you're curious, I'm just hitting Control-L each time to clear the screen, or you can type clear. I'm just going to go ahead now and type make hello, and all is well. Still an arcane output, but it's not an erroneous message. Now if I do /hello, and as an aside, / is unfamiliar to most. It just means dot means the current directory. So if you've ever used DOS or Linux or Unix, you might have done something like cd ... where ... means go backwards in time or go backwards or higher up in your directory. Dot just means look in the current directory. I want hello, which is right here. And indeed, now it says hello, Hannah. And if I change it again to Maria, recompile it with make hello, /hello, the program keeps changing. But this is still a pretty stupid program, right? If I want to ship this program or give it to a friend or give it to Maria or Hannah for that matter, that's fine. I can customize it for both of them, but it's never going to be dynamic. They can't change it once it's compiled down into those zeros and ones. So what if we did something smarter? What if instead of hard coding into the program this person's name, what if we just get the string on demand? So in other words, let me do this. I'm going to recompile this program, and let me zoom in at the bottom now. Make hello, /hello, and now nothing's happening. So could we get a quick volunteer to make something happen? Come on up. What's your name?
Pancho.
Pancho? Come on up. Once you get up here, this is going to be very underwhelming, but it's more interesting than me typing it. If you want to go ahead and type your name, I made this program just for you. Just type your name. Enter. Wonderful. All right, thank you very much. Okay. That was very kind. Here we go. So what did we do? So we finally at least made this program dynamic. Now, it's still certainly by design underwhelming, but we finally have the ability now to write code in advance, much like the authors of printf, and then dynamically adapt based on the input we are handed, either by the programmer or by the human who's actually interacting with the program. But let's actually now try to do a few other constructs and see if we can't make the programs themselves more sophisticated. So let's go ahead and instead of writing this one from scratch, I'm going to go into today's source code, and all of this is available on the course's website, and you can drag and drop it into your own environment come Friday once problem set 1 gives you the instructions, or you can do it at the command line as well, but more to come in pset 1. Let's see what's in this program here called adder.c. Now, I've already commented it, but what's new? At first glance, what line of code is absolutely new? But probably not fundamentally unfamiliar now. Yeah, so int x equals get int. We've never seen any of this before, but int is probably the symbol for what kind of variable? probably an integer, so int for integer. It's just being more succinct. X is just arbitrary. X and Y and Z are still pretty reasonable for numbers, but generally we'll use words once our programs get more complex. GetInt, of course, much like getString, is probably going to get an int from the user, and then we're going to do the same thing with Y, and apparently, even though this last line 24 looks more complex, it's going to say the sum of this and that is this other thing. And notice %i probably denotes what? What role does %i apparently serve? Yeah, it's just placeholders, right? %s was for string, %i is for integer. There's going to be %f for floating point value, which is just a number with a decimal point, in other words, a real number. So let's actually compile this program real fast and do make adder. Whoops. Good opportunity. So notice here, all this time, my username for this account is jharvard. I am in CS50 IDE, aka IDE 50. And now in blue here is a mention from the environment of where I am. And in fact, if I zoom up to the top here, notice that I have IDE 50, and I see this word, if you kind of turn your head to the side, workspace. In a nutshell, the fact that I'm seeing ~workspace means that in this text-based command environment, I am in the text equivalent of this graphical folder up here. So when I do /adder, it's saying no rule to make target adder stop. I don't know what that means, but it's bad for some reason. No such file or directory is even more clear. Where is it then? Based on where I clicked to open the file earlier. Where might it be? It's probably in source1w for Wednesday. And I can see it, indeed. If I open that up, there is adder.c. But in this text-based environment, again, I have to be super explicit. If I want to change directories into source1 Wednesday, I need to type cd space source1 Wednesday, enter. And now my prompt changes to give me a visual cue that I'm indeed elsewhere in my environment. But now I can do make adder. It seems to work. /adder. Give me an integer, 1, 2. The sum of 1 and 2 is 3. But if I don't cooperate, let's see what getInt does. Give me an integer, no. Retry, okay. Fine. 50, 50. All right, so it finally cooperates. And that's some of the functionality that these functions can have built in for you. So inside the implementation of getInt, what programming construct from last week is probably in there to compel this behavior of retry, retry, retry? Yeah, there's probably some kind of loop. It's going to look syntactically different from Scratch's blocks, but that's indeed what's inside the file. And in a few weeks' time, we'll actually look at the CS50 library as to what's inside, but there's a loop imposing exactly that. Well, let's play a silly little game here with this file, condition0.c. We're just going to generally start counting at 0. And I keep scrolling past some of the stuff at top. In blue here, demarcated with all of these stars and the slashes, those of you who've programmed before, what is that? Why do we keep skipping over it? What? Yeah, it's just a comment. This is a comment for humans to read that in our case tells us what the name of the file is, who wrote it, and what it does so that you don't have to read through the code to know what this file is all about. It's just a description, but functionally it's irrelevant and I can even delete it from my file and it has no impact. The juicy lines are these first two here now. Int main void is the equivalent of our when green flag clicked, so we're going to leave that be for today and we'll come back eventually as to what int and void are. But now notice what I've done here too. You can also, if you have an inline comment, if you have a thought you want to share about a particular line of code, convention in C is to do // and then a few succinct words, not a full sentence, generally not a paragraph, that just explains to you or your TF or other readers or colleagues what your code is doing. So rather than have to look at this and infer from lines 9 and 10 what is this doing, in line 8 I just give a comment that says ask the user for an integer. Then I don't have to think too hard about what lines 9 and 10 are. I just know that that's what collectively they're doing. How? Well, here's the prompt. Here's the getting of the int. And based on the previous behavior, it seems like getInt is smart enough to make sure that the human cooperates and gives it an integer. But now we see this. And this is reminiscent of Scratch. I'm claiming that I'm analyzing the user's input, but somewhat inaccurately. And this apparently in C is how we express an if-else, a branch, a fork in the road. But I say somewhat inaccurately. What's the bug in this program? How about further back? Yeah. Yeah, so if I type in 0, let's consider exactly that case, or corner case, if you will. So if I type in 0, which of the blocks is going to apparently grab it, the if or the else? the else, and it's going to say you picked a negative number, and indeed 0 is not supposed to be positive or negative, and so that would be erroneous. That would be a bug. So how can we fix this? Someone who's never programmed before, do you want, retracting? Oh, you have someone who's never programmed before. Want to try your hand on this? In the red shirt, come on up. Oh yeah, come on up, if you don't mind. So never having programmed before, what's your name? Lauren? All right. So fix this bug for us. You've not seen C, presumably, and probably no other language. So fix this program for us. Nice to meet you. No pressure.
Yeah.
But again, if this gamble goes according to plan, the takeaway here will be just, again, to start to notice patterns and infer from existing syntax how else you might express yourself, no pun intended, in order to capture some additional scenario. So we're saying else if, printf, good. And notice what CS50 IDE, and frankly, IDE stands for Integrated Development Environment. It's just a fancy way of saying a program that helps you program. It does user-friendly things like when you type one parenthesis, it automatically gives you the other, the presumption being that you're eventually going to want to type that, and it also does it with quotes. So I like line 23, 99% of the way there. Someone want to chime in with a tip? Okay, I heard semicolon from the audience. Good. So that completes that, and now just have a little consternation with line 21. How do we want to express this? What question do we want to ask, do you think? So previously we asked the question, if n is greater than 0, do this, else do that. So we need to choose a question to ask here. Good. So if n equals 0, excellent. So let's pause here. Thank you so much for braving this. Let me give you a little, okay, a well-deserved stress ball perhaps there. So we're almost there. And in fact, Lauren, if you don't mind, let me make one tweak here, just to be consistent even with what we saw in Scratch. What do I want to do with lines 21 and 24? Just again, based on how we did this in Scratch, perhaps. Yeah, move it up. So the else condition, the third or fourth or fifth or final branch, should indeed come afterward. And that's just by convention, just because, if you will. So I do need to make this tweak, and I need to put my curly brace back here. And now this program will compile. We're so close, but there's a very, very subtle bug. Let's see what happens. First, let me go ahead and zoom out. I'm going to go ahead and type make condition 0. Oh, I lied. Now the compiler is actually pretty smart, and I don't really understand its error message. Using the result of an assignment as a condition without parentheses is apparently bad. But what does that mean? Well, again, looking for patterns in code that we've seen before, what is line 17 actually doing, even though Lauren intended slightly otherwise? Yeah. Yeah, so remember that the equal sign, apparently as we've used it before, is not equals, it's assignment from right to left. So line 17 at the moment is a condition, and it's executing code inside the parentheses, but when that code executes, what is happening to the value of 0? What is happening to the value of n? Becoming 0. So if n is becoming 0, and again, as per last week, we generally say that 0 is false and 1 is true, or yes is 1 and no is 0. So true and false, 1 and 0. If n, as of line 17, has been given the value 0, is 0 true? No, by definition, 0 is false. That's the convention we're going to cling to moving forward. So will lines 18, 19, and 20 ever apply now, logically? They can't. So we ask the question, but not quite precisely, and you wouldn't know this unless you've seen it. The solution in C is when you want to express equality, you say equals equals. So equal sign was already used up by assignment from right to left. Equals equals means equals. And if you really want your mind to be bent, in JavaScript and PHP, there's equals equals equals, which means something else altogether, but we'll get to that before long. So this is the simple fix, but realize super easy to make this mistake and then wonder and struggle for minutes, if not an hour, like why is my code not executing as I intend? It's because you didn't tell it precisely what you meant. So that was almost perfect, and it was great that we stumbled across these two little things, because now if we've fixed them, and I do make condition 0 /, condition 0, I'd like an integer, please. Let's see. No, it's going to force me to do it. So 42, I picked a positive number. So now, how do I prove this program correct? Right? If you're a mathematician, you can't really prove this by trial and error. Right? You can't just proof by example. But at least as a programmer, we're not going to try to prove for now that this is actually correct, but I should probably test some representative cases. I've tested 42. I could test 43. I could test 44. Test 45, right? But I could do this a really long time. What would be some more interesting cases to try? So 0, certainly. And good, we've got it this time, thanks to Lauren's new code. What's another good case to try? And -1, and maybe something a little bigger, so maybe -42. But in general, when testing your programs moving forward, you're going to want to think to yourself, like, what are the fundamental different cases? And I dare say a negative case, a positive case, and a 0 case pretty much rounds these out. Let's look at a variant of this, though, conditions 1. This is a correct solution here, so that you'll see, too, and online, if you walk through the walkthroughs, we'll generally increment these stepwise until we get exactly the right approach. What if we wanted to ask 2 questions at once? Well, let me open up this instead. Non-switch, for reasons we'll see another time. What's new syntactically here? I'm currently playing a game where the computer is telling me, give me an integer between 1 and 10, and then I'm judging the user's input. In English, based on the code you see here in blue, what is this program doing? It's just adjudicating whether I picked a big or a medium or a small number based on a very arbitrary definition of small, medium, and large here. But notice the syntax that's new is this. There's no less than and or equal to sign or greater than or equal to sign where one is over the other that you can express in like Microsoft Word. So in a programming language, you typically just do 2 characters, one after the other. And what does this probably represent? Ampersand, ampersand. Yeah, it just means and, because it turns out that the authors of C used a single ampersand, which you might think would be perfect for the notion of and. It's already used up. So ampersand, ampersand actually captures the case we actually want. So let's now stumble across 2 things. Let me go ahead and open up something that's a little worrisome, imprecision.c. Let me introduce 2 things here. One, notice that we can do math, just as before when we did plus of 2 numbers, x and y. What is this program apparently doing? I've not commented it yet, and I've introduced %f, but I quickly said earlier, %f means floating point value, which is real number, something with a decimal point, which is not an integer. What do you think this program is trying to show me on the screen? Yeah. Yeah, what's the result of 1 divided by 10? Right, because all of you have probably grown up knowing that 1 over 10 is what? Yeah, this is 1/10 or 0.1, right? So let's see what this actually is. So let me go ahead and save this. Let me go down here, make imprecision, /imprecision. And notice, too, in a Linux environment, you don't have to type out imprecision and take all day long. Generally, if you hit Tab, it will finish your thought for you based on the words that are available in the current directory. OK, so you were right. 1 divided by 10 is, in fact, 0.1. But I'm a little curious, and it turns out printf supports some features whereby you can specify more than the default number of decimal points. So if I want to see 10 decimal points, I can do % for the placeholder symbol, .10 for give me 10 decimal points, and then still floating point value. And as an aside, what is this \n apparently we keep using? It turns out it's a symbol for a new line. It's the very explicit way of saying to the computer, move the cursor to the next line after you're done. And we'll see what happens when we don't do that. Let me recompile, make imprecision. Now /imprecision. OK, still right. 1 divided by 10. Now I'm getting a little curious, though. What if I look 20 decimal points out, recompile, rerun, and as an aside for speed, you can also use your up and down arrows to scroll through your history, so you don't have to keep retyping these commands. Enter. We've not learned that in grade school. All right, so let me see, like 29 places out. Maybe it's just a fluke. Maybe, it's my computer's acting weird. That's not a thing, right? It's doing something deterministically. So make imprecision. OK, that's messed up. So what is going on? So apparently, your teachers have been lying to you all of this time. for reasons that we'll see before long. But let's end with one other program. This is a little program someone wrote some years ago, and it's actually part of a contest. No one actually writes code like this, and if you do, this is stylistically a problem. But people do this for bragging rights, to write the most confusing-looking program that nonetheless does something interesting. And the note I thought we'd leave on today, before Colton plays us out here, is to run this program, which, even in just using C in this text-based environment, gives us this. Damn it. Stand by. Gavin C-LM. You're going to see the magical incantation that we'll see before long. All right, and now you can even do things like this. That's it for CS50. We will see you on Friday.
Upon them program. Upon them program. Upon them program.
Extent by default, literally introducing, thanks to Dan Armendariz and Dino and Dan Bradley on CS50's team over the past many months, a less comfortable mode that hides a lot of the initially confusing distractions. Everything there exists to represent a typical computer system that you might use in the real world. So what does this all mean, and what can we actually do with it? Well, let's actually take a peek at a program. So I'm going to open up the actual environment here, which is just a Chrome browser, which could be Firefox, could be Internet Explorer, or some other browser as well. It's full screened here for the moment, and I want to actually tease apart what this program was. So let's take a look by zooming in up top at what I did and how I got here. So here's those exact same lines of code. So this is the statement, as you mentioned earlier, or the function that says hello. The curly braces on line 4 and line 6 presumably kind of envelop that line to associate it with the essence of my program. So indeed, this keyword main that's up there on line 3, you can think of that as the equivalent of that when green flag clicked block in Scratch. So that's all we have here is when green flag clicked, print or say hello world. But let's take a guess now at what this first, more arcane line is. Sharp include open angled bracket, standard IO dot H, close angled bracket. What is that perhaps doing, especially if you've programmed before in some other language? Yeah. Yeah, exactly. So this is giving you access to a library, so to speak, of functions. And a library of functions is functions that someone else wrote, either recently or long ago, so that you don't have to reinvent the wheel. For instance, we don't have to know in 2015 how to write code that puts a character on my screen. Someone else has figured that out with the printf function so that I can sort of abstract away from that or layer on top of his or her code and now just take for granted that any program I write can print something to the screen. So this first line there in step 1 includes the so-called header file for the standard library. So C, the language in which we're now working, has a standard library with lots of functions. Printf is one of them, and that first line of code means give me access to those functions so that I don't have to reinvent that wheel. Now let's go to the bottom window and do exactly what I did before. A moment ago, when I was whizzing through the code, typing it out for the first time, I very quickly typed make hello. What was that all about, would you guess? What was I doing? Yeah. Never mind, it's okay. Yeah. Yeah, I was just compiling it, right? Even if this is completely unfamiliar to you, it's pretty English-like. It's certainly not zeros and ones, so I still need to run it through that so-called program, a compiler that's going to take it as input and produce output. And at least for now in this Linux environment, but this isn't prerequisite, this is just where we'll begin, you generally interact with computer systems like this via a so-called command line. So with a blinking prompt and your keyboard, and not so much your mouse, and not so much windows and icons and menus, rather everything is textual. And even though this feels at first glance perhaps like a step backward, it's actually a much more powerful and expressive way of controlling a computer, especially as you yourselves become more comfortable from less. It's going to allow you to do a lot more things than just what Microsoft or Apple allows you to do with their graphical operating system. So when I hit enter now, nothing happens this time because apparently the program hello is up to date. And what was the command I ran after that? /hello and hello world. Now let's take a step back for just a moment. It turns out that make hello is just a simplified way of compiling a program. Let's just introduce one piece of jargon, but then move away from it since it's not all that interesting for today's purposes. But the compiler we're going to start using is called Clang for the C language. And this is a program that's run just like we did at the command line there. And so if I want to compile a program that I have written in a file called hello.c, I literally just type clang hello c, enter. The funny thing is, for historical reasons, and just like Scratch had a little white placeholder for the number you would type in, so do we use in this text world parentheses to kind of give us that circular shape into which we can plug our inputs. After all, tens of years ago, when this language called C was invented, no one anticipated that one of us, some years later, would want a function that says hello. Right? It would be nice if there were a puzzle piece or a keyword that's called hello that literally just says hello, but we don't need that. We can have something much lower level, like a generic print command that takes input and prints whatever we want. So notice now the pattern that will start to emerge. Open paren, close paren is apparently embracing the input, and then I see double quotes on both ends. There's still a weird \n, but hopefully now you can start to visualize at least that printf is taking in some form of input. Not as user-friendly as Scratch, but it's just like having plugged in some value there. All right, now let's actually do something with this. So some of you might know from having shopped the class before or chatted with friends that for many years we used something called the CS50 appliance. This was a term describing a technology called a virtual machine, which is a piece of software that your predecessors would download off the course's website for free. They would also download a free piece of software called a hypervisor, something called like VMware or VirtualBox or any number of other tools. And on their Mac or PC or whatever computer they had last year and in years past, they would double-click an icon to run this software called a hypervisor. And then inside of that program, they would open the CS50 appliance. And the effect was that whether a predecessor of yours was running Mac OS or Windows, he or she then subsequently had a new window on their screen running CS50's environment. So a virtual machine lets you run one operating system inside of another, and that's exactly what we did. Throughout most of the course, we use an operating system called Linux, specifically Ubuntu Linux, and this is a very nice way in years past of making sure that everyone in the course just had the same environment, and you can use any kind of computer that you actually want. Among the downsides, though, whereas it was like 2 gigabytes to download this thing, it didn't necessarily work super well on people whose computers that maybe only had a gig or so of RAM or not too many gigahertz of CPU speed. And so this year, for this and other reasons, have we been transitioning to this environment, the so-called CS50 IDE, which is based on open source software and a supported platform that's a company called Cloud9 supports in Europe that allows us to have essentially that exact same environment as in years past, but in the so-called cloud. So what is the cloud? You probably clicked its icon on your Mac or PC. What is the cloud? Yeah. A little louder? Yeah, it's just a bunch of computers elsewhere that store data and run software and the like. So it's really just the word du jour of describing rentable computers that live elsewhere, that you and yourself don't necessarily own. So when your data or your programs are in the cloud, it just means it's on someone else's computers elsewhere and not most likely on your physical laptop or desktop. And so that's what CS50's IDE now is. Henceforth, you'll go to a certain URL that will introduce you to in problem set 1 later this week that will then, upon logging in, give you this environment. And much like Scratch had a few different panels involved, so does CS50's IDE have exactly that. On the top left-hand side here, you're going to see a familiar file browser. So any of the files that you put into this environment are just going to be listed there, files and folders. On the top right here, you're going to see a place where you can actually write your code, initially in C, later in the term in PHP and JavaScript, and perhaps for final projects, Ruby or Java or Python or any number of languages are supported in this environment. It's not at all tied to CS50 specifically. And then in the bottom corner here, especially for those more comfortable, you have something called a terminal window. And this terminal window allows you to execute any command that you want in this cloud environment. It allows you to install any additional software that you want because you have so-called root or administrator privileges. So in other words, even though this is ultimately hosted in the cloud, and even though we have simplified it to sums and ones, as our predecessors had to do some years ago, was not a particularly fun challenge. And yet this is what the computers still understand, so a compiler gets us from source code to object code. It's like opening a file with the compiler, and when you save it, you get those zeros and ones. So we'll see how to do that in just a moment. But let's now try to provide a bridge between last week and this, so that even as we get hung up on things like curly braces and semicolons and parentheses and all of these intellectually uninteresting aspects of programming that very understandably trip people up early on, realize that all of the ideas today are the same as last. So last we saw this example here, Hello World program. Well, starting today, if we want to implement that same program, it's going to look a little something like this. And we'll explain before long what int and main and void and all of that is, but at least I see here already the familiar Hello World. Meanwhile, things like functions, say hello, is very simply going to be a very simple statement like this, printf hello world, with some quotes, with a backslash, with a semicolon, but more on that to come. Loops, meanwhile, this is a loop that, of course, says hello world forever, and this one's going to look a little weirder than the last, but if I say something like while true, I can then print out hello world again and again and again and again. As you can kind of start to infer here, this convention of using curly braces is kind of like embracing the indented line of code there, the printf line of code, much like the yellow puzzle piece up above. So we're not going to say forever, we're going to say while true, but we'll see why that is in just a bit. Meanwhile, if we have a loop like this, where you repeat something a finite number of times, this one too, it's going to take a little getting used to, but it's going to say 4, int I gets 0, I less than 10, I plus plus, and then printf again. But there's going to be patterns. And for those of you familiar with AP Computer Science or Java or any number of other languages, almost all of these constructs thus far should look mostly familiar. So variables. So here's a simple Scratch excerpt that sets a variable called counter to 0, and then forever says the counter, and then it changes the counter by 1. So it starts with 0, and then 1, 2, 3. Well, how might we introduce that in this new language? A little similarly. Int counter equals 0, while true, which is that same idea from before of doing something forever. And I'm just going to printf, and now it's getting a little strange, %i, but more on that to come. But these ideas are exactly the same. We just now have to adhere to the syntax that the computer is going to demand of us. Boolean expressions, something like x less than y, or x less than y and y less than z, it's going to look a little something like this, with parentheses, just like in math, for good measure, to just ensure that the order of operations is as we intend. And now conditions. So if x less than y, say x is less than y. Else, if x is greater than y, say x is greater than y. Otherwise, logically, x must be equal to y. So you might implement something like this in Scratch, or you might implement it in this syntax. And again, the curly braces are kind of giving us the same shape as the puzzle pieces, but the syntax now is perhaps starting to follow some patterns. So what does this give us here? So we're back then at our main program. Let's actually now do something with it. So in this very first line, we see sharp include standard io.h and then some weird angle brackets. Below that, int main void, and then printf hello world. So just take a stab. Someone who's never programmed before, at least explain one of these lines, using perhaps some of the jargon of last week. What is printf, for instance? Yeah, it's a function or a statement from last week's terminology, and it's an action that's doing something. Now, this function or this statement, does it appear to take some kind of input? And in what sense does it seem to take input, if so? Input. What do I mean by that? So, Yeah, so Scratch had a few puzzle pieces where you could parameterize it. You could tell the repeat block how many times to repeat. So that was an input of terms of its shape if it makes logical sense to do so. But you don't have to stop with just doing one thing conditionally. You can have a proverbial fork in the road and do either this or that if a condition is true or not. And then, as you'll see if you haven't already, you can even nest these blocks. So Scratch grows to fill the shapes that you might want to insert into it so that you can actually express most any logic that you might want to do. Now, a few words of announcement for both here and New Haven. So sectioning begins today. The URL for this is on the course's website. For those unfamiliar, sections will be an opportunity to get together in a much more intimate environment than Sanders allows, with 10 to 20 classmates with a teaching fellow at different tracks and different paces if you so choose. Indeed, the course offers different sections for those less comfortable, more comfortable, and somewhere in between. And the rule of thumb here is that there's no formal definition, but you are, if you're less comfortable, you kind of know it. You're a bit intrepid about the idea of stepping foot perhaps back in the classroom or showing up to an in-between section. If you've been programming since you were 6 years old, more comfortable is perhaps to you, and if it's kind of a toss-up, that's exactly what the in-between is meant to be. Now, in the meantime, for a class this size, it takes us quite some time to section everyone, so we have so-called super sections coming up this weekend and early next week. So take a look at the course's website for those that are course-wide and also filmed for those who cannot make them. And sections themselves will start in week 3 of CS50 0 index. Problem set 0 is already on the course's website, and realize that you do have 9 late days this semester. So this is an upgrade from last year when we had 5 late days. So if you're wondering, we have 9 problem sets, and you have 9 late days, each of which that you can only spend 1 per week on. That effectively makes all of the problem sets due Friday, but the goal is to put a little bit of psychological pressure on you to try to get things in on Thursday, because as you will soon discover, for better or for worse, most everything in the software world ends up taking much longer than you anticipate. And so consider it a sort of opportunity to help yourself to target Thursdays, but take comfort in that, yes, everything is due Friday. And if you submit them on Thursdays, that's wonderful. There's no bonus points or extra credits for meeting that deadline. It's meant to be a crutch only. And office hours, both here and in New Haven, in person if you'd like to meet with any of our courses, teaching fellows and CAs for assistance. All right, so now let's make this more real. And for a moment, it's going to start to get a little more arcane, but very quickly on Friday and next week, will we be able to do so much more than we could thus far in Scratch. So we introduced code last week, albeit pictorial. It was puzzle pieces, and we formalized that as something called source code. But what did it look like? Well, it looked a little something like this. And in fact, just to kind of tease where we can go with this, I'm going to go ahead and open up a window here, and I'm just going to choose New File, and I'm going to save this file as something like hello.c. More on that choice of words in just a moment. And this is how someone might go about writing a program. Include standard io.h, int main void, and then open curly brace, close curly brace, printf hello, comma world, \n, semicolon, save, done. Okay, I've written my first program, but it's going to incredibly underwhelm because when I actually run this program, of course, by first writing make hello, and then /hello, and we'll go through this in much more detail in a moment. That's all it does. It doesn't pop on open any windows. It doesn't do anything particularly fancy. All it does is what I told it to do. But how do we get to that, and how do we build upon that? Well, let's introduce a few different concepts here. So one, we're about to start using a program called a compiler. Compilers exist for Mac OS, Windows, Linux, any number of operating systems, and we'll soon introduce you to the environment that we will be using. But a compiler is just a general term for a piece of software that takes source code and produces object code from it. In other words, if you have as input your source code, something like what I just typed, it ultimately produces object code. And object code is really just a fancy way of saying it outputs zeros and ones. In other words, source code, even though it's going to look a little arcane and a little less friendly than Scratch at first glance, it's at least something that we humans can understand. It kind of looks and sounds like English, even though it's very succinct, whereas programming in zero
of mathematical and mechanical skill is this great new automatic calculator at Harvard University. Intricate problems in mathematics, put through the machine in coded form on tape, are accurately solved in a minute fraction of the time required for human calculation. Designed to expedite all forms of mathematical and scientific research, the giant mechanical brain will work for the United States Navy until war's end.
This is CS50. The past was a magical place, but if you've ever wondered what that device is in Harvard Science Center, it's indeed part of the Harvard Mark I, and it's on display there now for the past many years. And what you'll see embedded in problem set 1 is a look behind the scenes at what that device did and does from Professor Harry Lewis, who's in the computer science department here. So more on that in just a bit. But today we begin to transition from last week to this, and we'll bring mention of one photograph here that's actually quite famous. Does anyone know what this here is on the screen? At least according to myth. Yeah. So supposedly the very first actual bug in a computer. Now, in reality, the word bug for a mistake in a program has been with us for some time in the physical world, and this was one of the first documented times where someone actually plucked a large moth out of the Mark II computer, put it in the binder, and then recorded it as the first known bug to have actually been found physically. So thus was entered that into today's lore. Everything from last week is available online, and in particular resources that you might not necessarily notice, especially if coming here in person. So one of the teaching fellows every year makes a canonical set of notes so that you needn't keep your head down trying to transcribe most anything that might happen here in class. So realize that those so-called scribe notes are online. Certainly the slides and the source code that we use in class, we make full text transcripts available as well. So if you vaguely remember some term and want to look it up a little more readily, realize that all of that is searchable online, as well as walkthroughs as well. Indeed, today we begin to look at a lower-level programming language, soon to be known to us as C, and it's very easy to sort of get lost after just a few moments' time, and then sort of wonder how we actually got to some more complex example from the simplest. And so realize we'll cherry-pick during class some of the representative examples, but realize that so much more is also available online so that you can work through it at your own pace, however you are most comfortable. But we left off with programs that were just this. So I click the green flag, and what does this program do? It says hello world, right? It makes the cat say hello in his little world on the top left-hand side of Scratch's user interface. But we started to introduce some terminology last week, and so things like this we called what? What might be the generic term for this? Yeah. A method or a statement, sure, it's an action, do this. And yet there were other shapes to Scratch besides the so-called statements. They were also things like this, which we called what? Yeah, so a loop. And in this case, this thing repeats obviously 10 times. There's a forever block. There's a couple of others. And today we're going to see how to translate this to a more modern world, if you will, even though it's going to appear at first glance to be much more arcane. But those were indeed loops. And then we had things like this, which had this shape and essentially asked questions. And we referred to these as what? Yeah, Boolean expression, something that is either true or false, yes or no, 1 or 0, however you want to view the world, but we called those Boolean expressions and we plugged them into conditions or branches. And in the world of Scratch, everything nicely interlocks and